So let's do this together. Okay. So again, we want to get the area of the triangle. So again, we have to get, the height, right? The height happens to be this leg here. Now, how do I know that? Well, because it's perpendicular to the base. Okay. So I called it B. I mean, you can call it X if you want. So how do we do that? Well, we have 9 squared, right, plus B squared equals 12 squared. So from Pythagorean's theorem, we get 9 squared plus B squared equals 12 squared, okay? And so, I don't know if I did write that, okay. So we have 81 plus B squared is 144. 9 squared is 81. B squared is just B squared because we don't know what B is, right? And 12 squared is 144. Okay. So then what do? Well, B is the unknown, right? So we subtract 81 and we get B squared has to be 63. But remember, we don't want B squared. We want B. So we take the square root and we get the square root of 63. And B is also in centimeters, so that's why I put centimeters here. So we have that. Also, someone asked a really good question. I hope everyone heard it. If you use the iPhone calculator, which you could, the square root you want to use has a little 2 up here where this red dot is. Generally, people don't write the 2, but it's understood to be a 2 here in that case. Okay, so now that we know what the height is, what's the area? Well, it's 1/2 base times height. So in this case, we get 1/2 times 9 times the square root of 63 centimeters times centimeters. So we get 35.71764 centimeters squared. And I did say to round it to 2 decimal places, so that's what I did here. And again, our units are in centimeters squared. Centimeters squared. So that's what the area is. Are there any questions about this? Okay, well, the next one's going to be a little bit different. Here, what I'm claiming is this. This is something that the book does go a little bit into, so I figured it'd be good to do this. Yeah?
Can you go back? I'm sorry.
That's okay.
How do you, sound very stupid question, but multiply that 1/2 times the 9 times the 6.
What do you mean, how do you multiply it?
Like, do you multiply like 0.5 times 9 centimeters?
I'm sorry, say again, please.
Like you just multiply, 0.5 times 9.
You could do that, yeah. 1/2 is the same as 0.5.
Oh, okay.
You could do that. Or you could do 1 divided by 2, and that'll give you 0.5, and then you can multiply.
Oh.
Does that make sense, or?
Yes, it does. Thank you.
Okay, awesome. Good question. Are there any other questions? Okay. Okay, so for this one's a little bit weird. Well, not weird, I should say, but it's different. That's a better thing to say. So here what we're asking is, can you have a right triangle where the legs have lengths 3 and 6 and the hypotenuse of length 10? So we're asking, is there a right triangle where this is true? Here, let me get the other thing actually. Can you have a right triangle such that this holds? Well, if it did, what would have to happen is it could look something like this. Basically, it's going to have to satisfy Pythagorean's theorem. You know, Pythagorean's theorem, right, is an important theorem about right triangles. So if we had a right triangle like this, okay, well, let's say this was the right triangle. It would look something like this, right?
Yes.
It would look something like this, right? Okay, well, what does Pythagorean's theorem say? Well, it says that 3 squared plus 6 squared would be 10 squared. But is that true? Well, if you work this out, the answer is no. Because you get 9 plus 36 is 100. And that is not a true statement. So we can't have a right triangle where this is true. So the answer is no. And that's basically what's happening here. I mean, if you did happen to interchange the 3 and the 6, the equation you get would be almost identical. That is, you would get 6 squared plus 3 squared would be 10 squared. And again, that would not be a true statement. Are there any questions on this? I know this example was a little different. It was different. Okay. Well, I do have another one as well. This one's similar. Well, let's now find x so that we have this as indicated in the right triangle. In other words, now we're assuming this leg has length 3, the hypotenuse is 10. Let's find the length of this side, which I'm calling x. I know before I called it b, but you know, bx, same thing, I guess. Anyway, okay. Anyway, we have by Pythagorean's theorem, x squared plus 3 squared is 10 squared. Okay, so we have x squared plus 3 squared is 10 squared. I know before I called x b, but that's okay. We have x squared plus 9, right, is going to be 100. So we're solving for x. We subtract 9, right? We get x squared has to be 91. And so, but we don't want x squared, we want x. We take square roots. Yeah? Okay.
Why would and sometimes you add like the 9, I mean, in one example you did like the 144 minus 181 and you left it there, and then here you didn't put it next to each other. I don't know if that's like just not doing like an extra step, or does that make a difference? I don't know if that question makes sense.
Because x's are unknown and we're solving for it.
Okay, I didn't. Okay.
I don't know if that helps or not. Let me see. You mean here?
Oh, never mind. That was that was something I did. Sorry.
Okay. I think someone had another question. I guess not. Okay. Well, anyway, so let me see how much. We have about a minute left. So, but basically, we get x is the square root of 91. And now I did round it to 3 decimal places. But again, normally I will tell you how many decimal places to round it to. I mean, here I should have said round to 3 decimal places. So, okay. I think the next one, yeah, this one would, this is another one that we can do next time. So,
I have a question.
I don't want to rush through an example. All right. Okay, so if there are no more questions, I guess we'll stop here because it's almost 11:50.
Wait. Excuse me?
Yeah. Yeah.
In order to like check your work, if you have a decimal place, how would you do that? Or would you just leave it as a square root?
You use the square root. You can do that.
Okay.
I mean, if you do use the decimal, you're not going to get the exact answer. You would get very close.
Okay. Thank you.
You're welcome. Okay.